Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of binary tree. That is nothing but convert sorted double linked list to the binary search tree. So before moving on to the question, if you guys are new to our YouTube channel, then please do consider subscribing our YouTube channel. And if you guys are the regular visitors, so without wasting time, let's move on to the question. Okay. So in this question, we are provided with a doubly linked list, and what we need to do with that is that we need to convert it into a binary search tree. Okay, so let's try to understand it. And here also, okay, so I'm assuming I'm provided with a binary linked list like 1 2 3 4 5 6 7, and we need to convert this into a binary search tree. Okay, so before moving on to this question, like how do we solve this question and how do we approach to this question, let I want to discuss one relatable question with that. Okay, we already know how to convert a sorted array into a binary search tree. Okay, we already knew it how to do it, just because we have done it earlier. Okay, so what was our approach of doing it? So let's discuss it. And how we solved it? Okay, we solved this. Okay, so wait, let me discuss the approach of solving that question. Okay, 1 2 3 4 5 6 7 and 8 and 0 1 2 3 4 6 7. So this is an array having the indexes from 0 to 7 and the elements from 1 to 8. Okay, and what we need to do is that we need to convert this sorted array into a binary search tree. So how do we convert it into a binary search tree? Was that at first we find the middle element. Okay, we find the middle element, that is nothing but the 4. In the case of the even number of elements, we get two opportunities. We get two positive members to get selected as the middle element, that is nothing but the 4 and the 5th, but we always choose the first element. Why? Just for the sake of convenience. Okay, just for the sake of convenience, we choose this number as a middle element. Now after choosing, what we do is we pass this array and this array to some recursive function with some feed. Okay, what will be that feed? We will discuss it soon. Okay, what will be that feed? We will discuss it soon. But what we usually do, we pass this part and this part to the recursive function with some feed, and our feed will be nothing but our faith was that this part and this part are capable enough that they convert themselves into a sorted, not a sorted, into a binary search tree. And when it completely converts it into a binary search tree, when it backtracks itself and reaches to the 4, its parent. Okay, when this binary search tree, sub-binary search tree, reaches to its parent, that is 4, its parent, that is 4, update its link with the binary search tree, because 4 has an feed to its children that they convert themselves, they convert those lists into some binary search tree. Okay, so till now I hope you get it. The second point is that why we are using this approach, why we usually use this approach of converting a sorted array into a binary search tree. We usually do this just because, yeah, we usually do this just because we know that the in order traversal of binary search tree is nothing but sorted. Okay, we know this, and it is a property. Actually, it is a property of a binary search tree that its in order is nothing but sorted. So using this approach, what we usually do, we convert the sorted array into a binary search tree by finding the middle element and then passing the first half of the list and first half of the array part and the second half of the array part to two recursive functions with some faith. Okay, so I hope you get it, that how do we convert this sorted array into a binary search tree. Actually, you don't I personally believe that you have solved it by yourself. Okay, actually the question which we are provided with right now, that is the converting a sorted doubly linked list, is nothing but just a little bit extension of this question. Here also we use the same concept we use in converting a sorted array into a binary search tree. We use the same concept here also, but the different part here is handling with the or dealing with the links. Okay, that is actually nothing but a quite difficult part while we say about it in the case of doubly linked list. Okay, I hope you get it. what we'll do today. So let's move further and let's try to understand better by working it on a doubly linked list. Okay, so I'm assuming I'm provided with a doubly linked list like this: 2, 3, 4, 5, 6, 7. Okay, 0, 1, 2. Actually, next it doesn't work in the doubly linked list. Okay, so 8. Usually we don't perform indexing in the linked list. So this is the linked list with which we provide with, and you can see here that it is a sorted. Now what will be your first step in converting it into a binary search tree? What will be your first step? Our first step will be nothing but finding the mid element. Why the mid element? Why the mid element? Just because we know that the mid element, because the mid element will be nothing but a perfect candidate to become a root node. And after making that particular node into a root node, what we usually do, uh, we usually break up two linked lists, two doubly linked lists, that is nothing but this part and this part, and convert these and pass this part to the recursive functions. Okay, pass this part to the recursive functions, and with a feed that these recursive functions will convert those lists into some binary search tree, and when they revert back, and when they backtrack, they will come up with a root node, and we just update our link with those root node. Okay, so what will be your first phase? Finding the mid. Now the second thing is that how do we find the mid of a sort doubly linked list? Okay, we already know that how to find a mid in a singly linked list, but we haven't performed anything on a doubly linked list. So what if I see that finding a mid in the sorted in a singly linked list is same as just finding a mid in a doubly linked list is same as just like the finding a mid in the doubly linked list. Okay, what I said, I'm really very sorry. So finding a mid in singly linked list is same as finding a mid in doubly linked list, or finding a mid in a doubly linked list is same as finding a mid in singly linked list. So why? So let's try to understand it. It is just because doubly linked list is nothing but a singly linked list with some extended properties. Okay, with some extended properties. What are those properties? The property of the doubly linked is that we can even access the previous elements. Okay, we can perform the previous iteration or the reverse iteration in the doubly linked list, but we can't do it in the singly linked list. But we know how to find the mid of a singly linked list. So as doubly linked is just nothing but an extension of singly linked list, so we can use its property. And we can easily find out the mid of a doubly linked list by using the same property of a singly linked list. That is, using two pointers, slow and fast. The moment fast pointer reaches to the null, we can see that at that particular point of time, the slow is not nothing but at the mid of a doubly linked list. So I'm not going to explain the approach of this finding a mid of the doubly linked list, just because we have made a whole video on that topic, and we have discussed a lot of things about finding a mid of a linked list on particular on that video. Okay, so I'm not going to extend this video discussing that topic. I keep myself okay, so I usually keep myself revolving around this question only. Okay, discuss only those concepts which are usually used in this question. So let's move forward. We were discussing the driver. So at first we find the mid, and we come to know that 4 is nothing but an active member of the active member as a mid. So what we does, we usually break the, after finding the mid node, we usually break its links. Okay, this the 4 have a links with 5 and 3. We usually break these links. Okay, and after breaking these links, we can see that these the all the nodes which lies before the 4 and after the 4 now become a part of the two doubly linked list. Okay, this become one of the linked list, and this become one of the linked list. So as these are the linked list, what we do, we recursively pass these elements into to the recursive functions. Okay, and while passing these while passing this linked list to the recursive functions, we have some faith. What are these faiths? That these lists will convert themselves into some binary search tree. Okay, and this list will convert themselves into some binary search tree, and when they revert back, we will do nothing, we'll just update our nodes, our links. This 4 will update its links with this link. Okay, so let's move forward. As we have passed this list into a recursive function, what we'll do again we will find the mid of this list. The moment we find the mid, we come to know here the 2 is a mid. The moment we find the mid, we will update its link. Okay, what we'll do while updating the links, we just do nothing, we just remove its links with its nose that lies before the mid and lies after the mid. So this 1 and 3 now become the single candidate. Okay, so what we do, as this 1 and 3 lies are behaving like a single node, they actually still working like the linked list. Okay, they are, we can say that these are the list of the single element. So again we recursively pass them to some other functions. Okay, these 3 are also passed recursively to some of the function, and here also we have the same fate that they convert themselves into some of the uh, accurate binary search tree. Okay, so moving forward, here at first one encounters that now there are no more nodes, and there is only one node in a list. Okay, so when there is only one node which is left as a node, there is when there is only one node which is left in a list, what it does, it backtracks, or it revert back with a conclusion that yes, I have converted myself into a binary search tree. Now you can update your link with me. It gives this conclusion to its parent. Okay, so one revert back or backtrack with some conclusion that it says to the 2 that yeah, I have updated my link with a 1. Sorry, I have converted myself into a binary search tree. Now you can update your link with me. So 2 update its link with a 1. Similarly, 3 revert back something to the 2 which is similar, which is absolutely same what 1 have done. Okay, so 3 revert back to 2 that yes, I've converted myself into a binary search tree. Now you can update your links, with me. Okay, as 2 has completed his work, what it does, it also revert back, just because we know that each node in a binary search tree have active 2 members, at most 2 members actually, and both of those 2 members have participated and are updated. So what the 2 does, to actually revert back or backtrack to the 4, and it during backtracking, it also provides the same type of conclusion that yes, I have converted myself successfully into some of the binary search tree. I have updated my left and the right children. Now you can trust me and you can update your left pointer with my position. Okay, so here you can see that we have worked on the left part only. Now let's working on the right part. Here on the right part, we works in a similar way. We find the mid, and the moment we come to know that there is some node which is behaving like a mid, what we do, we will break it into 2 parts. One part is the all the nodes which lies on the right side of the mid, and all those nodes which lies on the left side of the mid. So what I'll do here, at first I come to know that this 6 is nothing but a mid. So I break this links, and as this links get breaked, this 5 and this 7 and 8 are now get converted into 2 doubly linked list. Okay, this becomes 2 doubly linked list, and as this become 2 doubly linked list, what I'll do, I will recursively pass them into 2 different functions. Okay, 2 different functions. Now you can see that 5 is also a single node. As it is a single node, it reverts back and it passes some information. It passes some conclusion to its parent. Okay, it passes some conclusion to its parent that yes, I have converted myself successfully into some of the into binary search tree, and you can trust me. Okay, so what the 6 does, 6 updates its link with the 5 in a faith that that the 5 have converted himself into a binary search tree, but it have not updated its right side, just because in the right side there are multiple nodes lying. Okay, so let's work on the right side, that is on this part. In this part also, we will calculate the oh sorry so yeah, in this part also we will calculate the mid, and we come to know that 7 is a mid. Okay, as 7 is a mid, I need to break this links, but according to my faith or according to my intuition, what I do, whenever I find a mid, I need to break it into 3 parts. One is the mid part, which is the node which is actually find out during the imputation. Okay, and one of the linked list which consists of all those nodes which lies on the right side of the right side of the of particular node, and uh, similarly a linked list which consists of all those nodes which lies on the left side of that particular node. But here you can see that in the right side there exists one node, but on the left side there doesn't exist any of the node. It means, do we don't we need to pass anything? But no, we need to pass at least anything. Just because we are making the recursive call, if you don't pass anything, it don't work anymore. Okay, we need to pass anything. So what we will pass, we will pass actually null here. We pass here null. Here we pass the null, but on the right hand side, as we have some node, we'll pass here the 8. And as 8 is a single node, it rewards some information to the 7 that yes, my yes, I have updated, I have converted myself into a binary search tree, and you can revert back. You can revert back. You can update your link with me, and you can revert back your parent that yes, I have converted myself to a binary search tree. So 7 updated its right link with the 8 and backtrack and provide some information, similar type of information to the 6, so that 6 updated its right link with the 7, and similarly 4 updated its right link with the 6. So I hope you get the intuition or the workflow of this concept. What we are going to do in this question is that we are going to find the mid node each time, and after finding the mid node, we are going to divide our list into 3 parts. One part is nothing but a that mid node which actually find by the mid function. This mid node is actually behave like a how it behaves. It behaves like a root node. Okay, it behaves like a root node. Similarly, there is a left part and the right part. Left part consists of all those nodes which actually lies before the left part actually consists all those nodes which actually lies before the mid node, and right part of the linked list actually consists of all those nodes which lies after the mid node. Okay, so as this linked list get converted into 3 parts, one is a root node, this is a left linked list and the right linked list. This left and the right linked list get recursively passed to some of the functions with some faith, and that faith is nothing but they are strong enough that they will convert themselves into a absolutely fine binary search tree. Okay, and the moment they convert themselves, the moment they start backtracking, the moment they come up with some address, okay, what the root node does at that time, it will update its link with them. Okay, just because the root node is having a faith on them. Okay, so I hope you get it. Let's move on to the editor and let's try to code it. Okay, so here this is the editor, and now we are going to code in a C++. What will the first thing which we will do? The first thing will be nothing but finding the mid node. So for that I need to write the function. So let me write here the function node star get mid node, node star node, get mid node. Okay, if node is a null pointer or node right equals to null pointer. If any of such case arise, null pointer actually, any of such case arise, what I'll do, I will return node in that case, return node. But node starts slow. Now as I am finding the mid. So what I'll do, I will use the same approach, that is nothing but a slow and a fast pointer approach. Node starts slow, what it does, okay, while fast right is not equals to null pointer, and fast right. If you haven't watched that video, if you don't know how to find the mid of that mid of a singly linked list, if you don't know how to do it, okay, even on a singly linked list, then it's my request that please go and watch that video, because unless and until you don't get to find the mid of a linked list, you will not be able to solve this question. Okay, so please go and watch it. So okay, yeah, here if fast right equals if fast dot right is not equals to null pointer, and fast dot right is not equals to null pointer. Yeah, I got it. That was the case, null pointer. So it does. we update the slow with the twice speed. Not the slow, we update the fast with the twice speed. Fast equals to fast, next, 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 next. Okay, now we have completed the code of the get mid node, but we have not returned anything. We need to return the slow pointer. Why we need to return the slow pointer? Because the moment fast pointer reaches to the end, at that point slow pointer is actually pointing to the mid of a node. Now let's complete the code of sorted doubly linked list to BST function code. Okay, here also at first we need to check the base condition, that is if head equals to the null pointer, or head right equals to the null pointer. If such a case arises, I'll do nothing, I'll return the head. Okay, otherwise I'll do, I'll check if node star root. uh yeah from here I'm working according to my words. Okay, what was my words? My words was, at first I get the mid, so let me get the mid, get mid node. Okay, so at first I'm getting the mid. After getting the mid, I need to convert it into three part actually. One is the first doubly linked list, that is the second part as the root node, and third is the third doubly linked list. Okay, so let me convert it. Okay, node star left DLL head. Okay, uh, okay, wait. DLL doubly linked list head. So it will be nothing but head if root. Yeah, you might be thinking that here I'm writing something and you don't get it, so just wait for some time. Let me write it first, and after that I will explain you what I'm writing here. Okay, so head, similarly node star right DLL head, HEAD head. Here it will be nothing but root right. Okay, we know it. Okay, so here I have written something, that is left DLL head equals to root, otherwise null pointer and head. uh which case is it handling? Okay, it handling the case of two nodes. During the explanation part, explained you that there may be possibility that such a case arise that there are only two nodes in a doubly linked list, and after finding the mid we come to know that the first node is nothing but a mid node, and the moment I come to know that first node is a mid node, what I usually do, I need to break it into three parts. One is the root node, one is the left linked list, and the third is the right linked list. So as the list has two nodes only, and as the first node is nothing but a root node, so what and the right part have only one node, so what data will my left linked list will contain? My left linked list also need to contain something, just because this left linked list also will be passed to some recursive function. Okay, so means I need to add something to that. So what I'll do here, I'm checking that part. If I encounter such a case where my mid and the head of that linked list are same, means if my first node is nothing but a mid node, in that case I need to update my left linked list nothing but with a null pointer. Okay, so that case is doing nothing but behaving like this. And if anything doesn't like, if anything is fine, then it updated with the head. Okay, so let's move forward. Now what I need to do, I need to break the links. The first thing I'm again going to write is, there may be possibility you will not get it, but I will just wait for some time. I will explain you soon. Okay, root left equals to root left right equals to, actually root left right equals to null pointer. uh Similarly I need to update other pointer, that is root left equals to root right equals to right DLL head equals to null. I need to update all of them with the null pointer. Now what I'll do, I need to recursively call to the function to the left hand side and the right hand side. So this root which is right now created, I will update its left and the right by the recursive call. Let's see. Okay, so left DLL head and right DLL head. Okay, and at last what I need to do, I just need to return root. Okay, so let's discuss this case while breaking the links. Why I have handled this case. Okay, so we have discussed that earlier the case of two pointers where where there were two nodes in a linked list only, and at that time when we get the mid, when we were trying to access the mid, we come to know that the first node is nothing but a mid node, and at that time the left linked list was empty. So what we usually do in this case, we usually update our left linked list with a null. But we need to break the links. Okay, we need to break the links between the linked list. Okay, how do we do it? We update the left and the right pointer by null pointer. Okay, so as the left linked list is nothing but containing the null, and we are while updating the links, we are accessing the left and the right pointer. When we try to access the null's left and right pointer, it will give an exception. Okay, it will throw an error, and just to minimize those errors, just to get rid of those errors, I have checked this condition, just because it will throw a null pointer exception because we are trying to access which usually doesn't exist. Okay, so just to handle it, I have written this code, and means if my left linked list does not contain the null, in that case only I will update it with a null pointer. I will break this link. Otherwise there is no need to break the link because that actually doesn't exist. It is hard coded by us. Okay, so otherwise I'm breaking the roots left and the roots right, and the right doubly linked list had null, and those breaking those links and updating with the null pointer. After that, what I'm doing, I'm recursively calling to the left and the right side, and at last I'm returning the root. So that's all for this code. Now what I'm going to do is that I'm going to run it. So for that, and also one more thing is that if I encounter any of the error, we will solve it at the same time. So yeah, it get accepted. Let's try to submit it. Okay, so yeah, it is accepted, and the solution is also submitted. It means it passed all the test cases. So that's all for this video. If you like this content, hit the like button, share this video with your friends, and subscribe to our YouTube channel. That's all for this video. Let's meet in the next video. Till then, stay safe, stay healthy.